All right, so let's talk about this thing, domain and range. So basically, a really simplified, if you would stop talking, it'd be really nice. Are you the one that left your Tootsie Roll or lollipop on the floor yesterday? Because I saw somebody with a lollipop yesterday. I didn't say anything. Shh. But I picked it up off the floor. In fact, it seems like when you guys leave, I'm always picking stuff off the floor. So let's not use my floor as a trash can. We have a big old trash can over there. Okay, so if you have stuff you need to throw away, put it in the trash can when you leave the class. All right? So, anyway, that's that. Let's talk about this, domain and range. So, a real simplified, it's not even a definition, just an explanation of how to find the domain of something are just all the x values. So, if you're going to find the domain of something, it's talking about finding the x values. Well, this first little part may not make much sense to you, but later on when we look at this stuff, then you're going to look back and like, oh, okay, the domain is the x. I get it now. But right now you may not. All right, the range, take a wild guess what the range is. It's all the y values. Okay? All right, so for instance, this is example 6. It's a very simple example. So I'll just keep that there so you remember. So example 6, they ask you to find the domain and range. All right, it starts off really easy, super easy, almost elementary easy. But then at the end, it gets a little bit weird. I'll warn you right now. So you need to stay awake, you need to watch, because this is not your normal stuff that you're used to seeing in a math class. This is not just how to solve for x and things like that. It's kind of weird. All right, but they do a lot of this in upper level math kind of classes. All right, this is just the very beginning, the very, very basics of it. So they give you part A and part B. So part A says find the domain and range, and this is what they give you. They just give you several ordered pairs. All right, this is about as easy as domain and range gets. So they give you some ordered pairs. It's 2, 8. And they ask you to find the domain. I'll just put D for domain, is that right? And R for range. And they ask to find the domain and range. So take a wild guess. What do you think the domain is? -2, 0, and keep going. 2. Right. -2, 0, and 2. Because the domain are all the x values. So you look at the ordered pairs, all right, you find the x's, and you're going to write it as a set. All right, they usually write as a set, so we put those little braces on the end right here. And then you just list the numbers, -2, 0, and 2. And then you close it like that and put commas in between. So that's how they want you to write the answer. All right, they want you to write it as a set. You can put D equals or domain equals, it's fine. And then you just list the x values. So the range is just as easy. What do you think the range is? Very good. It's 4, 6, and 8. So there's a 4, 6, 8. Close it with the brace, and that's it. I told you, the very beginning of this is very elementary. Would you agree? Yeah, just look at the x's, look at the y's, put them down, no big deal. Now, we're going to take a huge jump up on this next part. So we start off super easy, and now it gets a little bit more complicated, but let's see what we can do with this. What I'm going to do, I should have brought it up already, but I'm going to bring up the Desmos app. Let's see. And I got it in my little bookmarks up here. All right. Now what I got to do is come back to this program and where did I put that? Right there. If I click on that. Now I got to click off. There we go. All right. Now YouTube sees it. And let's go back to this. Okay. So what I'm going to do is I'm going to put the graph in here just so I can show it to you. I can explain it to you. So again, we're going to find the domain and range. That's what we're going to do. So I'm going to put in that function. So it's y equals, what is it? 1 over, I'll tell you what, let's just do this. Put 1 over, and then what is it? X minus 2. So there's my x. Oh, minus 2. Starting to look kind of weird. But that's what our graph looks like. If you were to do like an X and Y chart, right, put a whole bunch of values in for X and then a whole bunch of values in and figure out what the Y's are going to be, this is what your graph is going to look like. Whoops. And I'm going to expand it out just a little bit, take it a little wider so you can kind of see what's going on. All right, so that's what the graph looks like. It's pretty crazy looking. I'm not going to ask you to graph this, okay? So on a test, I'm not going to say graph y equals 1 over x minus 2. Maybe at some other point we'll do that, but not with this chapter, all right? I just want you to see what the domain and range is. So what is the domain? The domain are all the possible x values. So for instance, if I was to like get to this point right here, I would go over this far on the x and this far up on the y. Would you agree? How would I get to, I don't know, some other random point, like right here? What would I do? I'd start here, I go over this far on the x, and I go that far on the y. So do we include all the x values? Are all the x values included on this? Well, everything from here to here to here to here, but then what's it start doing? It starts dipping down, doesn't it? And this right here, well, it starts way, way up here, and it starts dipping down this way. Or from right to left, it kind of dips up like this. Now, if I made it smaller and smaller and smaller, right, it starts looking like a straight line. Whoops. Sorry. Meant to do this. This is what I wanted to do. See what it's doing? This gets really, really, really close. Well, let's zoom in a little bit. To where? Look at this. This goes up and it gets really close to what number on the x value? On the x value.
2.
Right. Do you see how it's pushing closer and whoops, grab this. There we go. Do you see how that line's pushing closer and closer to that 2? Yes? All right. But guess what? It's going to get really, really, really close to the 2, but it's not going to what? It's not going to actually hit the 2, right? So 2 is not actually a valid part of our domain. But everywhere else, you could have an x value for it, except for where? At 2. So there's your 2 right there, even down here, right? So there's an x that shows up everywhere on this graph, except for what? 2. All right, let's go back to this. I got to switch this thing back now. There we go. Let's go back to this and find out why it gets really, really close to 2, but it never actually hits 2. Okay? What, to that graph? This is the question. This is the graph that we just graphed. This is the equation they gave us. All right, and I put it into my little graphing calculator thing. And then, so sometimes they'll give you an equation, and if you don't really understand that equation, what you can do is you can actually put it into Desmos and graph it and look at it. Okay? With the what? With that graph? The domain and range? Yeah, it does. All right. So, right. So what we're trying to do is find the domain and range. See, this is our equation right here. Okay? And this is the graph of it. All right? So what we want to do is find out all the possible x values. So really, I could keep going x values all the way to the left forever and ever. Like from here, from 2, I could pick an x value from here all the way to the right forever and ever. You see that? What's the only x value that does not exist on this graph? A 2. That's right. All right, so now let's take a look at this equation. Go ahead. For that graph? Oh, from this? Yeah? Okay. This is a different problem. This is a completely different problem. This is part A. This is part B. This has nothing to do with this. But what you did here, you found out all the x values. What I'm trying to do on this, I'm trying to find all the values for x that make this thing work. So I'm kind of doing the same thing. Kind of. All right? So I'm finding all the values for x. So could x be a 1? Could x be 1 here? Yeah, 1 minus 2, 1 over negative 1. That's fine. That'll work, right? X could be any number except for what? Except for 2. Why? You got it. You got it. Okay, now you see it. Because look, what if X was 2? Okay, I'm going to say, can X be equal to 2? No, it can't. Why can it not be equal to 2? Because then if I put an X in, if I put 2 in for X right here, I would get 2 minus 2. What's this? What's 1 over 0? Is it 0? Why is it an error? Because it's undefined. You can't divide by 0. All right? We've talked about that before in here. All right? You cannot divide by 0. It's undefined. All right? I'm not going to go through a whole reasoning why, because I could show you some examples and all that, but I'm not going to. But you just know that you can't divide by 0. It's undefined. It doesn't exist. It's not 0. Okay? It's not a 0. So 1 divided by 0 is not 0. It's what? It's undefined, which means it doesn't exist. All right? Whoops, there goes my pen. All right? So it's undefined. So X can be any number you can think of. It could be negative, it could be a fraction, it could be a decimal, it could be positive, a fraction, a decimal. It could be any number, a real number. Any real number that you can think of except for what? 2. So how do we write that? It can be all the numbers except for 2. Let's write that down so that we know what we're doing. All the numbers, so the domain can be all the numbers, all the X's, right? X could be any number that I want except for what? Except, did I write that? Did I spell that right? Except, I don't know, for what? 2. All right? Now, that would be a nice way to write it, but they're going to write it more mathematically, right? And we've actually done this before. Do you remember way back in the early days of this class, and we did like, we did this graph like this, and remember we said, I don't know, let's say it's at 1. Remember we did this? It's open, and then we shaded it in, and we did that. How did we write that, though? I forget. We called it some notation. I forget off the top of my head what we call it back then. I wrote it down. But how would I write this? Do you remember? So I put a parentheses. Since that's open, the parentheses means open, correct? So I put it parentheses. I put 1. I put a comma. What does it mean to keep on going forever to the right? What do I put here? Infinity. Very good. All right, so I put infinity. So this is how we would write that graph right there. Agreed? So let's think about this in terms of just the X. So let's use this since we're kind of used to that. Now remember, we'll put a 2 there. Why did I just put 2? Did I just pick 2 randomly? No, because I picked X could be any number except for 2. So let's put a little open circle there. It means it cannot be 2. But it could be any number to the left of 2, and it could be any number to the right of 2. Agreed? So I could shade this way, and I could shade this way. Okay, but I cannot include what? For the 10th time? 2. I cannot include 2. So how would I write this in this set notation, I think, or I don't know. They call it some kind of notation. Anybody remember? I don't know. I taught it. I guess I should know, shouldn't I? But anyway, it's called some kind of notation. So how do I write that? Well, I would write this. Let's make 1 to the left and 1 to the right. Let's do the 1 to the right because we kind of talked about it already here. Remember, this is open. It's like having a parentheses there, all right? So I'm going to put a parentheses, comma, what? It goes all the way this way. What do I put here after the parentheses, or after that? Put an infinity. So what does this mean? This means it's everything just a little bit bigger than 2, all right? It doesn't include 2. How would I show that it included 2? Do you remember what I would use? What symbol would I use? A bracket, right. I would use a bracket. But it does not include 2. 2 is not included. It's not part of my domain. So I put a parentheses there, which means it means everything just to the right of 2. I mean, as close to the right as 2 as you could possibly get, but doesn't include 2 and everything to the right. What about going the other way? How would I write that? I would also put a parentheses, but on the left, what am I going to put? I'm going to put negative infinity. Do you remember doing that earlier in the year? And then it gets all the way up to where? It gets just before the 2. So this part right here represents to the left. This part right here represents to the right. What we're going to do is we're going to join them together, and we join them together by a big old U for union. It's the union of those two together. So this is how we write the domain. It's weird, I know, but that is how we would write what the domain is. Okay? Write it down. All right, we're going to do a couple more of these, I think. Maybe one more. Let's see. Yep, looks like just one more. But that's how we would write that. I think that kind of makes sense, doesn't it? So again, what am I doing? I'm going to that graph, and I'm looking at the x values. And I'm looking to see what x's can be included, what x's cannot be included. Well, here at 2, I got to switch this back over again so YouTube can see it. All my, I was going to say dozens. I don't even have dozens of people that watch my YouTube videos. All my ones of people that watch the YouTube videos. I did get it. Did I tell you the other day? I got a comment from somebody. It was from the college algebra. Was it? I don't know. It was from one of my classes. And they said something like, "Greetings, professor. I'm watching from Algeria." So the guy's watching from Algeria, and he commented to me. It's in Africa somewhere. All right. So anyway, that was pretty cool. So there you go. All right. So anyway, let's take a look. So that's for the domain. What about the range? We're looking at this again. So what does the range mean? It means all the what values? All the y values. So can I include every single y value at all? I don't know. Maybe, maybe not. Let's go back to the graph and look at the graph. All right. So let's look at the y values. I'm going to, let's see. Oh, wrong way. I'm going to go like this. So look on the y-axis. See this line right here? Let's use the one on the right. Okay? Is it ever going to hit the y-axis here? No, but this does, doesn't it? That hits the y-axis. But how can I explain this? I'm lost for words. It's the same thing. Yeah, same equation. It's right there. See? It's the same equation. So now I want to find what y values, does it include every single y value at all? Well, let's look to see what happens here. Look, this gets really, really close to the x-axis, doesn't it? Everybody see that? It gets really close to the x-axis. And this one gets really close. Let me make sure I'm doing this right. Yep. This one gets really, really close to the x-axis. But is it ever going to touch? No. All right. Very good. That's an awesome way. Did you read that in your book, or did you figure that out on your own? Because that's exactly what it says in the book. You're absolutely right. So the y value for this, see this graph? It goes along the x-axis, doesn't it? But as far as up and down, how far up does it go? I mean, it goes up forever and ever and ever and ever. All right? So the y value's up. It can be any number. But look at this. It can never be what? 0. Right. Because how far down does it go? It goes down really, really close to that x-axis, but x-axis, if I could talk, but it never, ever is 0. Okay, it never goes to 0. Same thing with this. See how it's going right here? It never goes above the 0 on the y-axis. Everybody got it? So up and down. I'm thinking up and down. This thing going up and down. It goes left forever and ever and ever. But it only goes really, really close to 0. Like I could keep stretching this thing out. And what it's doing, that red line gets closer and closer and closer to 0 right? But it never hits 0. So that means what about about the range? It includes every single number on the y-axis except for what? 0. All right, let's go back. I got to switch this again. I wish it would just go back and forth, but it doesn't. Look at this. Now, Alex said it perfectly. If you have y, let's do this down here. I told you this was weird. All right. Do you see how this is 1 over something? What's the only way that y would be a 0? What number? I mean, what would have to happen to this thing right here for y to be a 0? Say it, Alex. You're dying. I could see it. The top number would have to be a 0, okay? It doesn't matter what this x is. There's no way that I could make this x anything to get y to be 0. So what's going to have to be a 0, or what does this thing have to be in order for this to become a 0? This would have to be a 0, but it's not. It's a 1, isn't it? Okay, if I put 1 over anything, 1 over 2, okay, if I put 1 over 100, do you see that? It's getting smaller and smaller and smaller. But I could keep going forever. I could put 1 over 1,000,000, all right? It's still not 0, is it? It's getting closer and closer and closer to 0, like that graph shows, but it's never going to be 0. I could make them bigger. Watch, I could get 1 over 1/2. What's that? That's 2, right? And then 1 over 100. It's still not going to be, that gets bigger and bigger and bigger. That's never going to be a 0. So I can never, ever get that thing to become a 0. So this is what we have. Let's just look at it on the x-axis. So here's the x-axis, goes up and down. Here's 0 right there. Remember, my graph, it goes up, 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 up. It gets really, really close to 0, but it never hits 0. Right here, it went like this, and it went like this. Watch, this goes down like this. It gets really, really, really close to 0, but it never hits 0. So that means it can be any number at all this way, and it can be any number at all this way, but it can never be what? 0. So how are we going to write the range? Let's do the up part first. Now let's do the negative first. I like the negative on the left-hand side. Let's do the negative. So you're going to put a parentheses there because it does not include 0. You're going to put a 0. Now, how far are we going here? Which direction are we going? We're going negative to where? Oh, I'm sorry. I should have done it the other way. You got to start down here. I'm sorry. You go negative infinity, there's negative infinity, all the way up to where? 0. But it does not include 0, does it? That's why I put a parentheses there. All right? And now, what's it going to do here? It starts at 0 and it goes where? It goes to positive infinity. All right? And what do we do to the two of them? Put a union right there, okay? So we're combining them together. That union right there is our range. So this is our range. So this one was our domain, and this one is our range. I told you it's kind of weird. All right. I don't know how else I can explain that. So we're going to go to another one, which is actually easier. This one's actually probably the hardest one out of all the stuff that we're going to do as far as domain and range. This one is kind of easy. So this is example 7. That was example 6. This is example 7. And it says find the domain and range of this equation right here, or this function. Okay? So what are we going to do with this? We're going to graph it, right. Now, do you need Desmos to graph this? Nah, you don't need. Nah, you don't. Tell you what, I'm going to grab, way up here. I'm going to grab a graph, copy that. Let's go way back down again. We should be able to graph this by yourself. You should be able to graph it by yourself. Have we done graphing in here? Like y equals mx plus b stuff? We have? Okay. Because I teach in my other classes. I just can't remember. I can't keep it straight which classes that I'm teaching it. So if I was to graph this, it's actually a very easy graph to do. So what's the first thing that I plot? The 1, the y-intercept. That's right. So I put a 1 and right where it hits the y-axis. What is this -2? That's my slope. All right. I could put it over 1. So the slope is rise over run. I start at my y-intercept. I rise -2, which means I go where? I go down 2 and I go to the right 1. All right. And now I just connect the dots. Now this one's nice because it doesn't curve. It just keeps on going. Okay. Everybody's got that part, right? Yeah, you should be able to graph that. I mean, put it on the Desmos app and you'll get the same exact thing. All right, but this was pretty easy. So what are we trying to find? We're trying to find the what? The domain and the range. Now, on the other one, there was a number that did not exist on the domain and there was a number that didn't exist on the range. What about this one, though? Are there any holes in this? There's not, because look, how far over can I go on the x? And then also get a point on that line. I could go here, yeah, then I could jump up here. I could go here on the x-axis and jump up to the line. I could go way out here and eventually jump up to the line, right? Because it keeps on going. Would you agree? Are there any x values that will not make this thing work? There's not. I can always have a y value for any x at all. So I can pick any x that I want, any x at all. So how do I write that then? How do I write every single number as far as this little thing goes? Yep. I could go from -infinity, right? Because x could go all the way to the left, and x could go where? All the way to the right. It could go anywhere from -infinity to infinity. This thing right here, you know what that shows you? It shows you every single real number that ever existed. All right, that's what that shows you right there. So I can put any value in for x. That's my domain. All right, so my domain is I can put any number I want in for x. What about the range? Give me a second. What about the range, up and down? If I go over on an x, will there always be a place I can hit the graph on the y? Yeah, absolutely. All right, I could go anywhere on the x, and if I go up, I'll eventually hit this line. If I could put anywhere on the x over here on the right-hand side and go down and eventually hit that line. So are there any y's that are out of play that I can't use? Nope. Every single y I can use. So guess how we're going to show that? -infinity to infinity. And that would be my domain and range right there. So if you just have a nice straight line, all right, then that's it. Okay? Everything's -infinity to infinity. I shouldn't say whenever you have any straight line, because you could have a line. Watch this. This isn't in the... Yeah, any line with... I hate to even say slanted, but anyway. What if we had this? What's the domain? What's the domain? The x value. This is 1, 2, 3. What is it? 1, 2, 3, 4. This is at 4 right there, okay? So how many x values are on here? There's only one x value, and what is it? It's 4. So what's the domain of that yellow line right there? It's only 4. That's the only x value. Because look, what if I went to 1? Could I jump over to that yellow line if I went over to 1? No, I could go up as far as I want, and I'll never hit that yellow line. You follow me on that? If I jump over here to 5, is there any way I could hit that yellow line? No. Okay, the only possible value for x is what? Is 4. So that's the domain, all right? Put it in a little bracket thing, all right? What about the range, though? The range of the y values. What y values does this yellow line have? It's got all the numbers, doesn't it? It's got every single number. How do I write every single number? -infinity to what? To positive infinity. So that's your domain and range of a vertical line, right? What if you had, what am I going to do next? Do a horizontal line, right? Did vertical. I'm going to do horizontal. Are you just not talking or? But you saw that. Okay, so what's the domain and range of the blue one? Well, what's the domain? The domain is the x direction. Are there any holes in the x direction? Are there any places that x cannot be? No. X could be any number whatsoever. Agreed? Right? Because I could go over anywhere on the x, go down some point, and I'm always going to hit that line. All right? Doesn't matter. So what's my domain then? It's negative infinity to infinity. What's my range, though? The y value. What's my y value? It's negative 2. That's it. Okay? That's the only, because no matter how far I go on the x, I'm always going to go what on the y? Negative 2. I can go this way on the x, to the left. And I'm always, to get to that line, I always have to go down, right? How far do I always go down every single time? Negative 2. So my range would be negative 2. All right? So that's how you would do, quote, straight lines, all right? This is horizontal, vertical, and a slanted one, I guess, if you want to call it that. That's how you would find the domain and range. Where it gets tricky is when you have, like, holes in the graph. All right. I think that's enough. So here's your homework. Bell's going to ring. Don't leave. We'll call it 2-4B, since it's the second homework, even though it's part D on the lesson. So it's page 134, and it's 61 to 72, but you're doing all of them this time. 61 to 72, and you're doing them all. All right, so this will be due what? Man, a long time from now. Not this coming Tuesday, but next Tuesday. This will be due. So everybody should have it done. Get it done tonight, because I know you're not going to do it during next week when you're off. So get it done tonight, and then... Right, Tuesday next week. Not next week, but the week after.